Thank you very much, Jeremy. So Lynda, tell us how biomaterials came to Morley.
Yes, so my name is Lynda. I'm head of school for visual arts here, but my area of practice is fashion. And in answer to your question about how biomaterials came to Morley, a few years ago I started writing a new fashion design BA. It was a standalone BA honors, Morley's first one in fashion design. And I started thinking about what could actually make us unique. We're a small provider, and what's great about that is you can be really adaptable. So I started thinking about what we could give students that that would help them in their industry progression, not just for the next 5 years or 10 years, but the next 20 years. Many of you who've been following sustainable fashion know that lots of things are changing in terms of rules and regulations about the types of materials that you can use, and we'll be talking about that a bit as we go through the lecture tonight. I really wanted to empower students to be able to progress into the industry for many years to come. So I started thinking about materials and how the role that plays, because we all know that fabric is very resource heavy. There's a lot of water, there's a lot of dye. Clothing manufacturing, there's a lot of waste. And so students of fashion and current fashion designers need to start thinking about how that's going to change over the next 10, 20 years. So that brought me to biomaterials. So biomaterials are things that you can actually grow yourself that are organic. So there's a whole range of different ones that we'll be going through tonight in the lecture. Here's an example of mycelium. And so I'm going to hand over to Jean, who can talk a bit about the first steps in our biomaterials journey.
So I'm the fashion technician on the BA course. I'm also one of the fashion tutors. A few years ago, we had a debate, when I used to be a student here, we had a debate about fish leather versus mushroom leather, and it seemed such a ridiculous idea. And I was on the debate team for fish leather, and I argued that mushroom leather was such a ridiculous thing. It was a fungus, it's going to colonise everybody and take over the world. Incidentally, since then, they've made that programme The Last of Us, but that's a whole other thing. I'm not responsible for that. But we have, over the course of the past 2 years, developed our materials lab just off our fashion studio. It's a small room. It used to be the IT suite, then it turned into the technician's cupboard. And now it's a fantastic little space where we manufacture all sorts of things, including the mycelium. We'll tell you more about this later, but mycelium, it's basically, for those who don't know, it's like the root structure network. It's not quite roots as such, but it does interact with plant roots. It's like little tendrils that come out from under the ground. The fruiting body is the mushroom. That's not what we work with. We work with that little mycelial network. Oh, I've got it written down here. Fungal strands called hyphae, like little tendrils like fingers reaching out to collect the nutrients from the earth. They vary in size. There's one in Oregon which is estimated to cover 10 square kilometres. So they can be, they can travel some distance. I've lost my train of thought now, I'm sorry. But yeah, this is just the example of one of the, you may change the slide now because I've gone off script. But
so that
already
took us on a bit of a journey about how this is what kinds of materials could we use. We don't have really expensive lab equipment. We don't have the facilities for that. We don't have the demand because we have small cohorts of students. So what could we be doing with students to really empower them in these materials without having to have a lot of expensive equipment? We started looking at regenerative fibers. So one of them is hair. And there's actually a lot of practitioners, some of whom have been really kind in helping us develop the curriculum that we offer. And there is a brand called Human Material Loop. And they're actually in the process of developing regular materials out of hair from hair salons. And they have all these statistics on their website. It's fascinating about how much hair we cut off and throw away every single year. But actually, that could be put to much better use. I mean, we all wear hair already. Anybody who owns anything wool, that's what that is. So the idea isn't that far-fetched. So we had some really fantastic practitioners that helped us. One of whom is a woman named Aurélie Fontaine, who is a circular luxury fashion designer, and I'll be referring to her periodically throughout because she had some really great insight and she's been really helpful with helping us develop the curriculum.
And talking of collaborators that we've met along the way, Natural History Museum.
Yes.
Yes. So a couple of years ago, the Natural History Museum reached out to us, possibly because they'd heard that we were starting this materials lab and beginning our practice, you know, practical practice, not just theoretical practice. And they asked us to take part in one of their Natural History Museum lates. Their theme had been chosen by their outreach groups, so it's, you know, come from people who are interested in sustainability, and the theme was fashion re-evolution. It was a fantastic night. The students had to make garments that were fully sustainable, so they could only use like donated fabrics. One of them made a dress from disused silk cocoons, which looked absolutely stunning. But yeah, it was a magical evening, and it was incredibly popular. Through that, we started working with one of their PhD students who basically came to Morley and collaborated with us and taught us how to set up our mycelium kit, for want of a better description, what we would need, how to do it, how to begin the process, and then our students began working with it as a material substance. We've had some mixed successes. Well, mixed results. We've had some real successes, mixed results. We've learned an awful lot over the past couple of years. But yeah, it's a really exciting area of practice, which we are even now really still at our beginning with. So,
yes, and I think that's something that's really important. We talked about between the two of us when we were planning this lecture, is that this is the ultimate in slow fashion. People generally talk about slow fashion as things that you make yourself or things that are really thought out and considered and time consuming. But actually, when you're talking about things like Scoby, which is on the screen now that Jean will talk about in a minute, this takes weeks or months in order to grow. So going back to Orly and how influential she was in developing the program she was talking about for her master's. She was growing trays of mycelium, and she said throughout the entire year she was doing her master's, she had 30 or 40 trays going of this at the time. So one of the things we'll be talking about also is scale. But at the moment, you know, you have to really think about the materials that you're using, because it does take time to develop the practice in order to have the results that you need to make your garments from.
yeah, because even working with the mushrooms. So yeah, this is the point at which I get excited and probably lose the plot again. This is a Scoby. This is a Scoby. This is a reclaimed Scoby from one that we already grew. This is the point. Prepare yourself, Scarlett. This is where I'm going to embarrass you. So Scarlett is our lovely artist in residence. She's one of our graduates, one of our very good graduates. She started working with Scoby as a project in your second year?
Yeah,
second year.
Second year.
Because it was a substance I'd never heard of until a couple of years ago. But it's so fascinating. It's the symbiotic culture of bacteria and yeast. So basically, it's kombucha and tea and sugar and a little bit of cider vinegar. Yeah, thank you. So this is it in the jar. Isn't it beautiful? I love it. I love it. I love it. It's yeah. It's like a little alien contained in a jar. Yeah. So that's it. This is a Scoby starter. So it's a similar process in lots of ways to sourdough bread. You take a starter, you use that to create more. You take a little bit out and you can recreate more and more. And this is where we come to the scaling. Are we there? We're not at scaling yet. We'll come to that. But yeah, so you start with this little starter thing, and some of them are literally that big. You put it in a tray and you add the ingredients, and then you just leave it. And the length of time that you leave it, this is where the slow fashion comes in. It's down to the length of time that you leave it, to the quality of the fabric-like substance that you get. So the bacteria and the yeast get together. There we are. That's one of our larger trays. So those are some starters going in. Don't they look delightful? They're gorgeous, aren't they? So that's basically a big bath of tea and kombucha and sugar. They love the sugar. That's very necessary. And you leave it. And if after a couple of weeks you get a very thin organza-like substance, the longer you leave it, you get a stronger layer, you need it to be nice and thick to really be able to stitch with it. But once you've taken it out, once you've dehydrated it, you can then actually, well, you need to keep it moisturised with like beeswax or some oil, but you can then stitch with it. It's a proper fabric. So that's one of our 2-week Scobies. You can see it's a little bit brittle to touch, but with the right treatment, it's still usable. So, and that in the corner is a little bit of mycelium. I like that one.
So why don't you talk a little bit about, because I as you were talking about what goes into the Scoby mixture, I know that, because I've been down in the materials lab, that along with Scoby comes some health and safety questions also pests.
Pests is a big thing. So Scoby is very popular amongst the fruit flies. I have recently learned a great deal about fruit flies. They are very, very excited by their olfactory senses, and they love the smell of a Scoby, and they are all over it like nobody's business. So if it's going to become a substance you want to work with, you do want to get yourself a fruit fly trap. Yeah, big. Or, I mean, look at that! Isn't that a beautiful texture? But yeah.
So what happens when you take it out of the tray?
It's very wet. It's very sticky. You have to lay some paper, you have to lay some protective surface around. You can't just lift one out and put it down. Laying it on something plastic that it can, there's the irony, laying it on something that it can peel off of once it's dry, that's really necessary. Making sure that the floor area is clean, going back to the health and safety, you know, you have to prepare beforehand with working with these things. You can't just walk to the cupboard, pull out some fabric, sit down and sew with it. It's different, it needs planning, and but it's still very, very achievable at home. So yeah, and there's some of our finished pieces on a half-scale mannequin. So it's work in progress still, but it's viable as a material to stitch with. So it's exciting and worth exploring.
So speaking of using it as a material to stitch with, so going back to the students and the way that we've designed the curriculum, one of the things that we wanted for year 1 students, they learn a lot about material. They learn about the difference between a plain weave and a knit and different fibers, wool, silk. So we've embedded a lot of our biomaterials into that year 1, because in order to be able to effectively use these materials, you have to understand the properties, and it really impacts your design process. So, you know, thinking about what materials you're going to use, what's reasonable in terms of quality and quantity, and how that's going to impact the designs that you're making is all really important. And also, how easy is it to stitch? What kind of stitches work best? What kind of seams work best? These are all the practical things that you need to consider if you want to start working with these materials in a fashion sense. So having that embedded in year 1, where students do a lot of sampling and they really get inspired by some of the work that they've been doing. I think we can talk a little bit about that. You know, some of the things that the students have been doing in their, we call it fabrication module, where they start exploring these materials and then taking the things that we talk about in class and really running with it and making it their own.
So here, this was our first root lace experiment. There's a company out there, I learned of them at the Material Matters trade show last year. Yeah, there's a company, Rootful, who do fantastic, beautiful work. You can look them up. But it got me excited, and I wanted to have a go at this. This is very, very, very basic experimental stuff that my lovely Ellie here knows about.
I actually have something to say. So I had some Wimbledon grass seed in my house, and I planted it under, because you know we said that we were going to do it under and try it. It didn't work, but I planted it on top, and it is so matted to the netting.
Well done. See, inspiring our students. There we go. That was mustard. This was mustard seed. It should really be grass. Grass is the ideal. Wheatgrass is allegedly the best one. This was mustard seed because it was the quickest thing I could get hold of from the supermarket. That was the quickest growing thing. We're trying to see here. So we're trying it on different fabrics. We tried this one. This is dress net.
Chiffon was the other.
Chiffon, and I don't know what the black fabric was. I can't remember. But we wanted to see if we could grow it through, and we did actually achieve proof of concept. So I'm really glad that you've taken that further, proof that you are making full use of your time here. So yeah, So this was Lynda's experiment at home, which actually went really quite well, didn't it? Up to a point.
It did.
Better than mine did.
It sounds easier than it is. You know, you kind of think, oh, okay, easy enough. Hydroponics, make sure that there's water there, put the seeds down, put the fabric on, let it grow. Wasn't that easy.
Yeah, just because you've proved the concept doesn't mean that you suddenly know how it works.
So this was quite interesting in terms of sampling. For those of you who are interested in trying some of these techniques, it's really about the testing. The testing is important. So as much testing as you can do, as much experimentation, and learning from that process, what worked, what didn't work. Not everything that we've done has been 100%.
Yeah.
But I always tell students, you learn a lot more from things that didn't go well than you do from things that worked properly the first time around, because you have to analyze and you have to really think about it. So in terms of root lace, I was testing this, it was an elastic material, and I was curious about what would happen if you got the roots to grow through the elastic and then you turned that into a garment that then stretched. What would happen to the roots? Would the plants still be there? Would it damage the roots? What would happen in that sense? And this is something that, when you're talking about materials, something else that we talk a lot about in terms of eco-fashion and eco-couture. So not only do designers need to start thinking differently about how they design, but I think we as consumers need to think differently about how we wear things. What are our expectations? So I was talking to my husband, and we were looking at this experiment and trying to figure out what worked and what didn't work. And we started talking about the problem here is the elastic. We're still using material as a foundation. We haven't gotten away from that with this process. So how can you go through this process and actually not have that waste? And we were talking about things like creating a foundation that isn't fabric, but is something that the plants will then feed off of, that then disappears as the plants grow, and then you're left with your root-shaped garment.
Yeah.
What about composting garments? We get used to bringing them to the charity shop or donating them or recycling them, but what about creating something that's so natural you could actually put it in with your compost and then it just goes back to where it came from?
I do have some thoughts on how to proceed with the... So going back to Rootful, they use intricately carved beeswax moulds, which at first puzzled me a little bit, but then I thought, well, it makes sense because then you can dissolve the beeswax and remove it, and then you've got your root structure. But we don't have intricately carved beeswax moulds currently. I've got some ideas on that too. But yeah, again, we're back to the experimental phase. So.
And here we have some yarn.
Some of our further experiments, yes. So this is alginate yarn. So I inherited this project, should I say. I inherited this particular project from one of my lovely tutors who's sitting at the back there. Going to embarrass you too, but yes. So it's made from seaweed. It's made from like the seaweed slime. It's dried and powdered, and then you can re-gellify it as and when you want to. So that's the sodium alginate there. The calcium chloride, it sounds like a very chemically name. It sounds like something, oh my gosh, what is that? They say they're using kitchen ingredients, but there's these chemical names. One is seaweed. The other one is actually used in cheese making, so it's actually really easy to get hold of. And it's to do with the way they flavour the cheese. So it's kind of like one of those umami flavours. But it cures the alginate yarn. So alginates are made from seaweed and a little bit of, I've forgotten the recipe off the top of my head now. But it's largely alginate, water and glycerol. Yeah? Thank you. This is why she's here. And then you extrude it, which is a great word, and it's a great process as well. So basically you whiz it up. You have to let it sit overnight. You can see we used some really high-tech equipment there, an old peanut butter jar. You have to let it sit overnight because you have to wait for the bubbles to rise to the top, and then you can use it. So we've got some syringes, we extract it, and then we put it through a bath of the calcium chloride, which is just powder mixed with water once again, so it's really easy to do. And you syringe it through. It makes a fantastic noise sometimes. And you have to be careful with it, give it a slow, steady pressure, but then you can actually extrude yarn-like fibre. And that's us winding it round a jar so that it forms a nice structure ready for us to use. If you keep it while it's sort of wet, but cured, then you can knit with it, then you can crochet with it. There are people out there who are making bags and accessories and even, you know, even net-like dresses currently. So it's one of those things that's, you're going to hear more about it. You might be hearing it here for the first time, but you're going to hear more about these sorts of things. And here we are, you know, these are our yarns curing in the lab. So it's a great texture. I love it.
So one of the other avenues that we've looked at, because this is something Jean and I talked about when we were thinking about the course and how we were going to prepare for the lecture today, is a lot of people have one area of practice that they work on, and they spend years refining it, and they really understand it, and they know that a lot of their work is based on a kind of a singular process. But as educators, we need to be concerned about doing lots of different things. So we have to be showing our students a really diverse range of processes and materials to really get, because you know what is inspiring to one student may not be inspiring to another. And the same is true of us in terms of processes.
Well, this is it. I'm a seamstress and a pattern cutter. I'm not a biochemist, but I've got excited by this stuff. It's really interesting. Fashion has to take a good hard look at itself, just generally. And I think these are viable processes. They're going to take some work, they're going to take some refinement, but we're coming back to the scaling up soon, aren't we?
We are. So
yeah.
Here we have onion-dyed bioplastic with mold.
Yes.
Does happen. That's one of the things that you kind of need to figure out and address and overcome because of the moisture involved. If the atmospheric conditions aren't right, you do end up with mold on your samples. And so this was one that Jean and I made. It was a bioplastic, which was, as I say, dyed with onion skins. But because of the way that we made it and when we made it, it ended up going moldy. But actually, sometimes the mold is quite pretty.
It was really
and
beautiful,
creates a lovely.
I'm kind of tempted to try and find ways of doing something with the mold.
So we've been working a lot with things like biomaterials and bio leather and bioplastic. So this is an example of more of a leathery type. And this is something, as I was saying, about people having to rethink the way they wear fashion. A lot of these processes at the moment are very sort of stiff and leathery. So we have to think about how that might work for the way that we dress. We're used to wearing things that are much more free-flowing and allow for much more ease of movement. So from a design perspective, you have to really consider what kind of silhouette might be suitable for this type of work, which is why you typically see it used in accessories at the moment more than full garments. So in terms of the sort of the leathers, here's one that Jean's been pioneering in terms of using.
It's my current obsession is the orange peel textile. We haven't perfected it, but we are working on it. So these are the dehydrated orange peels, which we then powder up. And again, that just requires simple kitchen equipment. You can, if you've got a coffee grinder, that's great. If you haven't, a pestle and mortar. But you can give it a really good bash with a rolling pin if you have to. But so we got a really good texture to start with, but then we haven't perfected the recipe, so it's still a bit dry, it's still a bit crackly. We were attempting some buttons in the little blue mould there. Initially they were a little bit cakey, weren't they? And then they just went very, very rock hard. And we need to refine this. We've tried it a couple of times. We haven't given up yet. So this is one of our works in progress. This is one of our first attempts at the bioplastic.
Bioplastics are super easy recipes.
Yes.
They really involve gelatin, glycerol, water. That's basically it. You have to get the right mixture and you have to get the right process.
And you don't have to just use gelatin either. You can use the agar because not everyone's happy using the gelatin.
So this was our first experiment. We wanted to show you a little bit about the journey because these are small samples, but we've learned a lot from the process in terms of repetition and scaling. So here's our first attempt at biomaterials. One of the things that we struggled with was that they curled as they dried. So it was very difficult if you're thinking from a fashion perspective that you need sheets of things in order to be able to cut them and shape them. It's not very helpful if they don't dry flat. So we did struggle with that one at first. We also were messing around with recycling fibers. We have a lot of threads and things in the studio, and we kind of thought, oh, that might give it more structure, because a bioplastic actually, when you're looking at it from the perspective of wearing and movement, it might crack.
Long fibers and short fibers.
We tried hair.
Yes.
We tried a bunch of different things. So this is our sort of our second attempt, and it was really mostly about kind of understanding a process that would give you consistent results. So here's where the testing is important. I recommend anybody who's working in these kinds of materials that's testing them for themselves, keep a journal. What did you do? Exactly how much you used? How long did it sit for? How long did you stir it for? What was the temperature on the stove? It seems really pedantic, and we were talking about this, about how you not only have to understand sewing and pattern cutting, but you also have to be a bit of a scientist and understand about those kinds of things, because that does really impact on what your results are. So this was our second attempt. And then by the third attempt, it was working quite well. We did a lot of research on the internet, and we found some really helpful graduate papers from people who were doing this kind of work as their graduate projects in university, and they published their results. Much like my grandmother, they don't always give you exactly the right recipe, but they do give you some helpful information that will help you in your projects, and then it's a little bit more trial and error from your perspective. So one of the things that we like about bioplastic, of all the materials, it's my personal favorite, because I think it aligns really well to the type of fashion that I do in fabric. So I can get similar results for the design aesthetic that I work in using bioplastic. And what was nice about this is these were all just cut. You can laser cut it, you can hand cut it, you can stitch through it. So it has a lot of promise in terms of a material. And so this was my second example, and we learned how to keep it from curling. So on one of those blogs of some helpful grad students mentioned about how you have it dried. So Jean earlier said you need to dry some things when you take them, like Scoby, you take it out of the bath, you have to put it on a dry surface. But bioplastics you should pour on a perfectly level, flat plastic surface. And the first time I tried it, it worked incredibly well. We didn't have a perfectly flat surface, and what happens when you do that, if you're pouring liquid on a perfectly flat surface, or on a surface that's not perfectly flat, as you can imagine, gets thicker on one side, runs off the other side, but as a test, it sort of worked. And then I've progressed to this. So I've been trying to add color. A lot of people will say use food dye as a color. I find that doesn't work very well. We've tried it a lot. We've put food dyes in our plastics, and they don't really seem to get that vibrant color. So I was messing around with charcoal. I did a couple of samples where I couldn't get the solution to really solidify, and I decided that it was the charcoal that was affecting the scientific compound. So instead I added it afterwards as a sort of a decoration. So the yellow underneath is actually the piece of plastic that I was drying this on. And then this is what happened. I let it dry overnight to the point where it was partially solid. It was enough that I could pick it up off the tray. And then I draped it over a plastic mannequin to let it harden. And I added a few glasses and things I had kicking around in my kitchen to try and give it some shape, and left it there overnight to dry. So my next step will be to have multiple pieces that all form together and create an actual garment. So anybody who's familiar with the work of Iris van Herpen, who was one of the original pioneers of 3D printing, her garments weren't printed as entire pieces. They were sections that kind of all worked together because of the nature of the 3D printing. Very much the same approach I'm going to apply to this. So have different pieces that then all work together. So in terms of progress, I think in a few tests, I've gotten some really good repeatable results. And so this is kind of one of the things we wanted to share with you in terms of empowering anyone who's here that's interested in trying these, that once you get that sort of testing, you can learn from that very quickly and create results that are much more predictable.
And we were having a conversation about the shape of garments and kind of going back to the scaling it up, but not how you have to do it in the sections, but it kind of takes it back almost like to historical, garments, because they would come in different sections. So it's very futuristic, but it's, very fashion at the same time. So
we're going from my favorite to yours, Jean.
Yes, this is my favourite, the mycelium. So we're back to the root-like structure of networks and such. So those are the little white tendrils. Those are the hyphae reaching out to find their nutrients. That's such a great photo. And the little square in the middle is a piece of mycelium that was taken from a mushroom and put in a petri dish and fed agar. And the white bits going out, that's the fresh mycelium. once that reaches the edge of the dish, you can then harvest that and inoculate, that's what we call it, inoculate larger surfaces of, to scale up the mushroom, and not mushroom, the mycelium. That's our students harvesting it and preparing it to go in the petri dishes. And yeah, it's just such a great fabric once you've actually prepared it. Again, it takes time, and you have to, these are our sterile conditions at the moment. We are going to get a laminar flow hood so that we can actually do it inside the lab in proper sterile conditions, but for the time being we have our little sterile tents, because otherwise you get contaminated, and we've got a slide coming up where you'll see what happens when it gets contaminated, and then you get a battle between the bacteria and the mycelium, because they are living organisms. They are things that are going to fight for life, and they will battle it out with each other, which is quite exciting. That is my favourite thing. You don't really get the scale of how tiny that little mushroom. It's about that big. It's about that big, but they're just so perfectly formed, and it's come off. That's actually a fruiting body. Sorry, I get very excited by this one. That's actually a fruiting body that comes off of the mycelium. So we don't really want to grow fruiting bodies. We want to grow that white structure. We want to be able to take that, and once it's fully formed, once it's nice and thick, then we can take it out and harvest it and heat press it, and then you've got your mycelium leather. But every now and again, and this is it through the microscope as well. And again, we don't have big scientific equipment. This is a little microscope that we've got just off the internet, and you can attach it to your phone and take these photos, which is what I've done. So that's the underside. Sorry for anyone that doesn't like the holes. Sorry, but yeah, this is the underside of the mushroom, and this is what I was talking about. So this is when it gets contaminated. The bit in the middle is the original piece of reishi mushroom, reishi fungus that we took off a tree just up the road in the park, and unfortunately some contamination got into the dish as we were putting it in there, and that could literally just mean that, you know, somebody breathed over the top of their mask or something, and some bacteria got into the dish. But it's just so beautiful because the way it's just formed these circles is really quite lovely. But we didn't want bacteria. Such is life. But yes, and here's another sample of the mycelium. So what we want is really the thick white stuff, and then we can take that and make it grow bigger and then create our pieces of mushroom leather.
So Jean, what advice would you give anyone who is interested in here in terms of mycelium? If someone wanted to start working with mycelium, what have you learned in terms of keeping it sterile and getting more consistent results? Because I'm assuming a lot of these are from the earlier stages, and that as we've gone through,
yes,
things are getting, you have more consistent results.
You would think we have more consistent results. What we have learned, what I have personally learned, is when you harvest your first piece of lovely A5 size mushroom leather, weigh it down with something so that it doesn't curl up like a pork scratching over the weekend while you're away from it. So yes, that now sits in our what not to do jar and comes out for display purposes. But yes, sterility is the key to it. You have to keep the area sterile. The easiest and quickest way to do it would be to do it over an open flame, which I know sounds terribly dangerous, but you know, it sterilises the air around it. Failing that, you need something like our tents that we have to keep the area completely clean, because even breathing on it, you have to wear masks, you have to wear gloves, you have to sterilise everything with alcohol to kill off any possible bacterial infections or even the yeasts that are naturally formed in the air. Because the slightest thing that gets into it is going to change what's happening in the dish. But once you get over all of those things, if you get, and it takes perseverance, and it also takes a small element of luck as well, I think. But once you get past those things, you can create a really lovely textured, you know, beautiful piece of mushroom leather. And it smells wonderful, doesn't it, when you heat press it? There's nothing like that fragrance. It's lovely. Everyone walking past the room wonders what we're doing in there. But the texture of it is quite lovely once you've got it. So it's worth persevering. It's worth, and it's actually really accessible. Did we put the slide in with the ratio on the tree? I can't remember. But
no. It's
basically that mushroom. You know, you can take that mushroom off the tree, use a very sharp knife, but be very careful. Be very careful. It's that mushroom that grows on the trees that you'll see up the park. The bit that we originally started with was taken literally from the park round the corner. And then you just peel off the outside layers and get the bit that's inside, the uncontaminated bit, and that's where you begin. But yeah, that's back to is that the underside again? That's the underside
that's
of
the leather.
Piece. Oh, that's the actual leather. Yeah, so this is our attempt. Another medium that it grows on, so it doesn't just grow on agar, which is basically seaweed, and also full of nutrients. It will grow on sawdust. So the one that we work with most is Ganoderma, and there are about 80 species of Ganoderma mycelium fungus in the world, at least. And a lot of them are decomposers, and they love feeding on rotting wood and things like that. So we were using sawdust here. We were trying to grow a neck piece. We had some success. It did grow mycelium. It also grew a few mushrooms, like we've done here. So, yes, thank you very much again, Scarlett. If I'd have harvested that mushroom last week, it would have been edible. They're great. So these are is this a ratio? Or is this an oyster? It's oyster. I thought so. Yeah. So the oyster ones, you can eat them. So you get a dual benefit. So you can grow it from oyster mushrooms. You've grown it from stalks as well, haven't you?
Yeah, I'd say oyster's the easiest one to grow. So like. You
Yeah, it's the quickest and the easiest, isn't it?
Yeah,
the reishi.
like just store-bought oyster mushrooms.
Yeah. And yeah, but I love that piece. So the white stuff that you can see underneath the cling film, that's actually the mycelium. So we're trying here to grow a piece that will stay on a body. So we're aiming for garments. We're going to get garments. I'm going to get the mycelium gloves. I said this last year. I was hoping to have it for this year. We haven't got it for this year, I'm sorry. But next year, there's another year to go. So thing we've learned this past year, next year, who knows where we'll be.
Very true. And also, thinking about from a design perspective, something that's important for the students and also for anyone who's interested in working in this kind of material for garments, you need to kind of really rethink how you create design. So from a fashion education standpoint, it's taught in a very linear way. You get your idea, you do your research, you do your sketching, you do some sampling, you test your patterns, then eventually you make your garments. It's very procedural. But I was at a thing called the Future Fashion Showcase up in Leeds, and it was all about these people who were doing all kinds of alternative practice around fashion. And one of the people there was someone who was pioneering the idea of 3D weaving. So her concept was that if you are weaving garments already in 3D, you're eliminating the need for cutting and sewing and waste, so it actually is a much more sustainable approach. And what she said, which I thought was so interesting, and has stuck with me ever since, was that she got a lot of interest from established designers. It wasn't as though people didn't want to employ her technique. The problem was you have to design completely differently if you're going to be using 3D weaving. You can't sketch in a traditional way and then turn around and say, great, I'm going to 3D weave this now, because the two things don't match. If you're thinking about your garments in a way that is the old way of kind of cutting and sewing, you're not taking into account this kind of material and how it behaves. So you need to start by thinking about design in a completely different way. And that's something that's we're really embedding in all of the curriculum that we do here, where we're working with students about what the future of fashion will be. So, in conclusion, Jean, what would you like to say for people to encourage them to go out and try some of these materials?
Oh, definitely. Don't find it intimidating. Don't think that you can't have a go. This is part of the reason why we're doing this. This is part of the reason why we've got the biomaterials course. Most of the time, you would only have generally had access to this kind of knowledge or to this kind of process by doing a degree. But why? Why should you only find it that way. We want people to go away and get excited about these things and try these things at home. There's, you know, Morley is just populated with people that sew at home, do art at home, do all sorts of things at home. And that's why you come here to refine your skills. Why can't this be another skill that you come here to refine? You know, we want to encourage you to just give things a go. See the things that you have in your kitchen, can you use them in a different way? You know, with just 1 or 2 added unusual ingredients that you might not normally use. Can you create these fabrics? Because they don't just have fashion purposes, do they? You know, you can use them for artistic purposes, you can use them for other things. I mean, I'm going to go off on the mycelium again, I'm sorry. But mycelium is being used in architecture. They are building actual houses out of mycelium in certain areas of the world because it's a thing with real fantastic properties. It really holds things together. We have to perfect our own practice here, but you know, it's a really good substance. Can I mention the self-healing robot skins? Through some of my research I was doing for this they are making self-healing robot skins out of mycelium. So we're not the only ones working on the textile aspect of it. They're also looking at using it in space. NASA are doing some research with it in their research centres to look at using it for building things out off planet, but which I, as a sci-fi geek, find very exciting. But yeah, it's like, come to Morley, come do the courses, come find out more about these things. Go away, look online, look up whatever area of it that you're interested in that you might have just had your appetite whetted with this evening. Go away, find out some more about that. Give it a go. Just give it a go. That's always going to be my advice, is give it a go. Because you don't know what you might achieve, you don't know what you might find out. You might be the solution. There's a lot of problems in fashion. It causes a lot of problems in the world, and we need to find some solutions of those. And I say it quite often, who knows, maybe the solution is here in Morley. Who knows? In closing.
Yeah, absolutely. And I think some of the things that you said were really interesting in terms of other applications. So we've been talking about eco-couture and how we could use these things from a fashion perspective, but also there's opportunities for jewelry, for sculpture, for all kinds of things, product design. And so one of the things...
I told you off for not wearing your root lace necklace, didn't I?
That's very true.
So.
One of the things that we want to do with this is also make it much more accessible to people and really empower people to try it for themselves. As Jean said, you know, it's anybody that's established practice in this field has started off just like any of us. Someone who's just has an interest and wants to make a positive change. So we hope that you've taken something away today that you might like to go home and try. And thank you so much for coming.